Hello everyone and welcome back to my channel Monica Math Classes. I hope you have seen my previous video on rational numbers. So today we will finish the other part of it and we'll see that how the questions are related to those properties of rational numbers. But before we begin, I want each one of you to like and subscribe the channel, which will help me to move forward and give you more guidance and simplify the concepts. So let's enjoy the journey, all of you. Do you remember what we have done last time? The properties of rational numbers, and we have seen how do we actually do that. I have simplified it, and I want all of you to go back again to the previous video and see it again. If you want to know that where it is, I will leave the link of the previous video in the description. You can go with that. Okay. So today we will see that what kind of questions actually we have in our textbook. So the one which I can see it right now is this one. Multiply 6 upon 13 by the reciprocal of minus 7 upon 16. Do you know the reciprocal again? Do you know what is the reciprocal of minus 7 over 16? It is upside down, yeah? So I want each one of you second. There is a slight orientation problem with the device. Okay, so I got it. So multiply 6 over 13 by the reciprocal of minus 7 upon 16. So what is the reciprocal of? So first we should know what is reciprocal. That is multiplicative inverse. Yes, reciprocal of minus 7 upon 16. It is nothing but minus 16 upon 7. Okay, so what is the question saying? Question is multiply 6 upon 13 by the reciprocal. Now reciprocal is minus 16 upon 7. So do you think anything can be divided? No, you cannot cut 6 by 7 or 16 by 13. That means I have to multiply numerator with the numerator. So 6 times 16, what it is? It is minus 96 upon, and 13 into 7 is how much? 91. And there is only one negative, so answer is minus 96 upon 91. An easy one, but it is something you should understand that how we are applying the reciprocal part over here. Okay, so let's move on to the next one. Is 0.3 is the multiplicative inverse of 3 whole 1 by 3. This is actually 3 whole 1 by 3. Now, this is something, a very good question, and I like personally this question. Okay, so is 0.3, first of all, you understand the decimal and the fraction part. How can you write this? Okay, so 0.3 can be written as 3 upon 10. Do you all agree with this? Yes. Okay, so this is 10th place, so it means 3 upon 10. And 3 whole 1 by 3 can be simplified further. This is a mixed fraction. Convert this into improper fraction. It is 3 times 3, which is 9. 9 plus 1, 10 over 3. Okay, so now if we want to check that are they multiplicative inverse or not, so what we have to check? 3 upon 10 into 10 upon 3. Do you think what you're getting? 10 can be divided by 10. 3 can be divided by 3. So the answer you got as 1. So they're asking you, is 0.3 a multiplicative inverse of 3 whole 1 by 3? Answer is yes. It is a multiplicative inverse because a number and its multiplicative inverse or reciprocal, when you multiply, gives you 1. And my answer is 1. So the answer is yes, it is. Okay, so you will write it proper that why it is so. Okay, so when your concept is clear, it is very easy for you to apply this in the questions. Okay, like in this one, reciprocal and the previous one. Now let's see the another one, using appropriate properties. This one question when I've seen in many school people ask because they want to know which property you are using it. So let me first of all write it properly, because here you're going to use commutative property, distributive property, associative. So what it will be? So first of all, write the question. Minus 2 upon 3 into 3 upon 5 plus 5 upon 2 minus 3 upon 5 into 1 upon 6. Now, tell me, this question, can you rearrange? Now my next step would be rearranging it. So if you see the multiplication, one term is this and the second term is this. I'm going to rearrange them. Okay, so I'll write it first before this plus 5 by 2. So my next step is minus 2 upon 3 into 3 upon 5 minus 3 upon 5 into 1 upon 6. So I have written this first, okay? And then plus 5 upon 2. Now, while rearranging this term, okay, when I bring this last term first over here, so that means I'm using commutative property. If I change the order of the numbers, even then my answer remains the same. Do you remember commutative property? Okay, so this is commutative property. So you all have to write this in the bracket, that what property you are writing. So you have to mention it. And that's the purpose. And there will be some marks attached with it when they write using appropriate property. So this is a commutative property. So you need to mention it. Okay. Now, what do you see between these two terms? This 3 by 5 is common to both. Okay. So you will take 3 upon 5 as common. So when you write 3 upon 5 as common, what you are left with inside? Minus 2 upon 3 minus 1 upon 6 plus 5 by 2. Yeah. Now, how do we further simplify? The brackets first. So in bracket, you have fractions. So how do we solve the fraction of addition of fractions or subtraction of fractions? You have different denominator, you make the denominator same. Okay, you have to take between the LCM of 3 and 6, it will be 6. So when you take LCM as 6, what it becomes? So here you have as 6 as the LCM. So between 3 and 6, I hope everyone knows 6 is the LCM. So this become minus 4 and this become minus 1 because 6 is already there, plus 5 by 2. Now, when you solve it further, so you have 3 upon 5 and here into minus 4 and minus 1. Same sign add, negative sign. Okay, keep the larger one. So here plus 5 by 2. Now here it's very important that you write the next property. You mentioned, what did you use? You use distributive property here. Okay, now can you see this 5 and 5 can be cancelled, can be divided, and 6 can be divided by 3, you got 2. So I'm just making a separate part over here and finish it. So you got here, after solving, you got minus 1 upon 2. And here you got plus 5 over 2. So minus, now you have same sign, okay? Now you have the same denominator. So minus 1 plus 5, you only have to look at the numerator. So this becomes 4 by 2 and the answer is 2. That's my answer. It's a very important one, easy. So you need to make sure that you remember that what property you are writing here and how you're solving it. So it is a step by step. So first of all, you rearrange the terms. The one term which is written, okay, later you can bring it forward and you write down that this is a commutative property. Take common between both of them, simplify the bracket, and it will take you to the answer. I hope this is clear. Okay, so now let's see the next one, which is a very important again. Representation of rational number on number line. All of you have learned how to represent integers on number line. So that's our basis. Okay, so first of all, let me just draw a line. I am drawing a line, not so straight, but you have to assume this is a line. Line, and I have put arrows on both the side. It means that it can be extended in both the direction. Now I will name it as a number line when I put numbers to it. 0, 1, 2, 3. And you have to make sure that the numbers are at uniform distance. The distance between the two numbers should be same. All of you have to remember it. Okay. So between 0 and 1, whatever distance you are keeping, 1 centimeter, 1 inch, it should be same. Between 1 to 2 should also be same. Between 2 and 3. Have you seen your ruler or scale? Have you seen how the distances are always same? How it is divided into 10 equal parts between 0 and 1, 1 and 2? Okay. So same you have to keep in mind. Have seen your ruler or scale? Exactly, you have to make it over here. So right side is always positive and the left side, it is always negative. Okay. Now, how do we represent? That's the question. Your first question is 7 upon 4. So for this 7 upon 4 or any rational number, positive or negative rational number, you always have to look at the denominator. Denominator plays a very important part. Denominators are very important. It is 4. That means I have to divide this number line into 4 equal parts. How? Between 0 and 1 into 4 equal parts. Between 1 and 2 into 4 equal parts. Okay? Let's see how it will be. So if your denominator is 3, I have to divide into 3 equal parts. If my denominator says 5, I have to divide it into 5 equal parts. Now it is telling me as here it is 4. So I'm going to divide between 0 and 1 as into 4 equal parts. Let's say. So 1, 2, and 3. I have to mark 3 lines. These 3 marks which you are putting up in between 0 and 1, it should also be seen. Okay. So this represents my 1 by 4. This represents 2 upon 4. This represents 3 upon 4. And the 1 over here, when it becomes 4 upon 4, it becomes 1. Can you see that? Yes, it's correct. Now next, again you have to mark 3 equal distance over here. So it will divide it into 4 equal parts. See, this is my one part, this is my second part, third and fourth part. So after 4 by 4, 5 by 4, 6 by 4, 7 by 4, and 8 by 4, see, 8 by 4 becomes 2. And the point and the number, it is 7 by 4. So I have to circle it, and you can point out or you can give some letter to this. You need to give some name to as P, A, B, C, whatever letter you wish. So you can give some name of the letter here and it becomes the 7 upon 4. Okay. So this is how you're going to represent. So any rational number. So always your steps or process are same. There is no difference. Okay. So look, first of all, my first rule is look for the denominator. Now the denominator is 4. That means I have to divide between 0 and 1 into 4 equal parts, between 1 and 2 into 4 equal parts, between 2 and 3, 4 equal parts. Now the point is, how do we know where the 7 by 4 is? By looking at it. Now the 7 by 4 is a proper or improper fraction. This 7 by 4 is an improper fraction. Yes, because why it is an improper fraction? Because numerator is greater. Yeah. So when numerator is greater, in that case, I will know it's an improper. So it will go beyond 7. It will go after. It will go after 1. Okay. So whenever you have something like improper fraction, always remember you always will get a point after 1. 7 by 4. So when I change this, I'm just simplifying. So after 7 by 4, when you change this into a mixed fraction, that means it will go by 1 whole 3 upon 4, right? This is how you change it. That means after 1, my third point is the point which I will get. So you want to check it further, you can verify. After 1, this is my 1, right? I'm highlighting it again. First, second, third. See, my third point is my 7 by 4. I hope you have clear with this. We will do one more as minus 5 upon 6. So we will draw another line. Okay. Now, because I'm doing freehand, so it's not very proper, but this should be a straight line using a ruler or scale. Okay. So now minus 5 upon 6. Tell me this minus 5 upon 6 first. Is it a negative or positive? Negative. So it will always be lying towards left side. Okay. So first thing is clear. If it is a positive, it will always lies towards the right side. Now this is negative, so it will always towards the left side. Second thing which you need to know, minus 5 upon 6. This 5 upon 6 is a proper or improper? What it is? Proper. That means your point will lie between 0 and 1. If it is improper, then it will go beyond 1. I hope this is clear. So let's begin. So first of all, because it's a negative rational number, so always it will go towards left side. Next, one thing which we need to know is that, which I told you before, while marking some distances, what it should be? Denominator. Now the denominator is 6. That means I have to divide into 6 equal parts. So that means between 0 and 1, I need to divide into 6 equal parts. So first of all, okay, let me take small one over here because I have to go towards left side. So first, it is your minus 1 over 6. Then you have minus 2 over 6. Then you have minus 3 over 6. Then you have minus 4 over 6. Then you have minus 5 over 6. Then you have minus 6 over 6. And this minus 6 over 6 is minus 1. Okay. So between 0 and minus 1, this is my point, minus 5.6. Okay. You can name it as A also. Now between minus 1 and minus 2, again you need to divide it into 6 equal parts. Suppose if they say minus 7 by 6, so where it will lie? It will lie after minus 1, minus 7 upon 6. If they say minus 8 by 6, so it will lie over here. I hope this is clear. So whatever your denominator is, you need to divide it into that number of parts between 0 and 1 and 1 and 2. I hope this is clear. Yeah. So if I give you something, which is 7 by 12, if the denominator is 12, even then you should know that I need to divide my number line into 12 equal parts between 0 and 1 or 1 and 2. I hope this is clear now. Now, the next very important concept in rational numbers in grade 8 is this: find rational numbers between two rational numbers. So the question is, if they ask you that, how many rational numbers lie between two rational numbers? So your answer should be infinite. You can have as many as you want. They are countless. You cannot count them. So they are countless. So infinite. So anything you can write. So if in question they ask you find 5 rationals between 2 by 3 and 4 by 5. So let's see, observe it, and then we will move forward. So between 2 by 3 and 4 by 5, whatever they give you, okay, I'm solving the first question. 2 by 3 and 4 by 5. First of all, check how many rational numbers lies between. I say infinite, but how? We need to show it. So check first. The first step is check, are the denominators same? No, denominators are not same. So what should we do? We have to make the denominator same. And what's the step for that? You have to take LCM. So between 3 and 5. Okay, this is the denominator. So the LCM for both of them is 15. So I have to make the denominator as 15. So what should I multiply 3 with? 5. Same, I need to multiply with 5 over here. Okay. And then here I need to multiply with 3. Okay, so what do we get? 10 over 15, and here we get 12 over 15. Now, they're asking you in between 10 and 12, 10 upon 15 and 12 upon 15, because we made equivalent rational numbers right now. Can you have 5 rational numbers in between 10 and 12? Answer is, how many between 10 and 12? Only one, which is 11 upon 15. I want 5. How do I make it 5? So whenever you have to get 5 rational number, 6 rational number, you just, multiply with 10, the easiest route I'm telling you. So you can have as many as you want. sometimes after teaching, I found that after 17 years of experience, I give them the easiest way. 5 is something you just multiply with 6, you get 5 in between. But I say, and you also do the same thing, what I'm saying it. So when you have to find out between 10 over 15 and 12 over 15, 5, or they have ask you 6, 8, 10, you just multiply with 10. You can have as many as you want. And all the answers are correct, okay? Because it varies. You get 100 upon 150, and then you got 120 upon 150. Now, in between 100 and 120, you have as many as you want. Yeah? So between 100 and 120, you have 101, you have 102, you can have 111, you can have 115, 115, you can have 117. So it varies, and you can write as many as you want. So you want 5, you can write 5 in between. You want 7, you can write 7. You can find 8, 10, as many as you want. So 10 is the solution. I'm giving you this trick, which is very easy. Otherwise, in the textbook, they have asked, if they ask you 5 rational number, you just multiply with a higher one, which just multiply with the 6. You get the answer. That is also fine. That is also not wrong. Okay, that is also correct. But I find multiplying with 10 always make your calculation very easy, and it's a simplified version of it. So I always like to do it, and much more easier. So why not try and go with the easiest one? So understand the concept. So as soon as you get something, first of all, make the denominator same. And denominator same you can do only by taking LCM. Then afterwards, you find out, do you get the answer? If your answer is no, I did not get it, then you just multiply with 10 up and down in both rational numbers. And then you can write as many as you want. That's your final answer. Now, similarly, when you have minus 3 by 2 and 5 by 3, you can also have as many as you want, but one is a negative rational number and one is positive. In that case, it's very easy. You can write after making the denominator same, after getting something which is easy to write. So you can quickly find out the 3 rational number, because one is negative and positive, so you can find all the range in between. So that one is much more easier. Yeah. So I want that you can just go with this method which I have told you right now. So we have reached to the end of rational numbers, and I hope children, all of you have understood very well about the rational numbers. So go through both videos, and in any case, if you have any doubt, you can leave. You have any question, you can leave the comment, and I will give response to each one of you. So what we have done today, let's do a quick recap. So we have done today how to solve uh, any question on rational numbers using the properties of it, and whether it's a multiplicative inverse or commutative property. So generally you get such questions which we solved today. And also then there are two more very important, which is how to represent rational numbers on number line, which we have seen, and another one, how to find rational numbers in between two rational numbers. The answer is infinite, countless, but if they ask you 5 rational numbers, if they ask you 10 rational number, so you have to follow the same method, making the denominator same, and then afterwards you multiply with 10 or 100. I mean, just multiply with tens and hundreds, because your simplification is much more easier. Yes. So I hope children you have enjoyed today's learning. So again, I would say that is my best liner always, that practice, practice, because practice makes the man perfect and permanent, and also make them confident. So happy practicing and happy learning. Keep practicing. And by then, rise and shine, Monica. Yeah, all of you. Bye.